Hello everyone, this is Dr. Abdul Pasha, dealing the course Power System Operation and Control. So in this, I'm going to explain excitation systems. So what are excitation systems means? Excitation systems are the key sources in the power system network which makes the system to run according to their excitation levels. That means here we will discuss some key features regarding excitation systems. That is, one is about functions and performance requirements of the excitation systems. Second one is elements of an excitation system. What are the various blocks and what are the various counts that should be included in excitation system, that we will discuss. After that, types of excitation system. That means classification of excitation systems. Control and protection functions of the excitation systems. Modeling of the excitation systems. Coming to the first case, that is the functions of the excitation system. So here the functions of the excitation system are to provide a direct current to the synchronous generator field wind. We have alternator case. So to produce the power, for this we need to give the excitation that will be associated with direct current to the synchronous generator field winding, and it is to perform control and protective functions are essential to the satisfactory operations of the power system network. So here the performance requirements of the excitation systems are usually determined by generator considerations. The performance requirements of the excitation system are usually determined by generator considerations. So here supply and adjusting the field current as the generator output varies within its continuous capability. That means it will respond to the transient disturbances with field forcing consistent with the generator's short-term capabilities. So for rotor insulation failures due to high field voltage, rotor heating due to high field currents, stator heating due to high VAR loading, heating due to excess flux in volts per Hertz, these are the parameters we must consider. And another condition is power system considerations. That means contributing to the effective control of the system voltage and improvement of the system stability. That means we may consider the elements of the excitation system as shown with the components of the excitation diagram. Here we are applying reference signal case to the regulator part, and here is our exciter, main exciter. This is connected on either sides with one of the regulator case, another one with the generator case, and this block is coincides with the terminal voltage, transducers and load compensations, and this block is again connected with the power system stabilizers to make the operation smooth. Finally, this block is connecting to the limiters and protective circuits to go connect with again to the back end of the regulator circuits. So here the generator end is connecting to the power system network wherever we need to transmit the power. So likewise the components of the excitation system will follows with, one is exciter, second one is regulator, third one is transducer and load compensator, fourth one is power system stabilizer, and finally limiter and power protective circuit. So coming to the exciter case, which will provide DC power to the generator field wind. Here the purpose of the exciter is it needs to provide DC power to the generator field wind. Coming to the second one, regulator processes and amplifies input control signals to a level and form appropriate for the control of the exciter case. And third one is terminal voltage, transducer and load compensator, which will senses generator terminal voltage, rectifies and filters it to the DC quantity, and it will compares with a reference signal. That means load compensation may be provided if it is required to hold the voltage at a remote location or remote point. And fourth one is a power system stabilizer, which will provide additional input signal to the regulator that will make the damping of the power system for number of oscillations. And fifth one is limiters and protective circuits. Here it will ensure that the capability limits of the exciter and generator are not supposed to be exceeded. Coming to the classification of excitation systems or types of excitation systems, the classification is three broad categories that is based on the excitation power source, that is DC excitation system, AC excitation system, and one more is static excitation system. Coming to DC excitation system, it will utilizes the DC generators as a source of power. That means it will be driven by a motor or the shaft of the main generator. So that may be self or separately excited, and it will represent early systems in 1920s to 1960. So they lost the favor in the mids in 1960s because of which are in large size superimposed by AC exciter voltage regulators, which will ranges from early non-continuous to the rheostatic type, and it will be again connected to the later systems using magnetic rotating amplifiers. Likewise, DC excitation systems may follow. So if you observe the diagram for DC excitation system here, which will be considered with the amplitude voltage regulators. So what is this amplitude voltage regulator means? So here it is connected in such a manner that the field is excited here with this amplitude. So this will provide excitation to the most of the field winding, and this is one of the field connecting to the armature, and it is acting for DC exciter. One of the slip rings are provided here, to one with the field, another with the armature. This is called as main generator, and this block is known with the DC exciter case. So this extension is connected with CT and PT, and this block is superimposed as feedback path to the voltage regulator case. So again, this feedback path is given to the one of the armature set. So likewise, DC excitation system with the amplitude voltage regulators are going to be considered. So here amplitude means it is an electromechanical amplifier. It contains an electric motor driving a DC generator. The signal to be amplified is applied to the generator's field line. That means its output voltage is an amplified copy of the field current. So amplitude is here used in the industry in high power servo and control systems. That means these are ready to amplify the low power control signals. So it is now almost absolute in nature. So here we will depict the simplified schematic diagram of a typical DC excitation system with the amplitude voltage regulator case. So this is the diagram that we are representing here. So this will be the diagram which will depict the simplified model for a typical DC excitation system. This is considered with the amplitude voltage regulator. So self-excited DC exciter is going to supply current to the main generator field that will be through the slip rings. That means exciter field controlled by the amplitude, which will provide an incremental changes to the field. That means this is connecting in a buck boost scheme. So exciter output provides rest of its own field by self-excitation. So AC excitation systems, that means it uses AC machines like alternators as a source of power, which will be usually the exciter which is on the same shaft as the turbine generator. So AC output of the exciter is which is rectified by either controlled or non-controlled rectifier circuits. So rectifiers may be stationary or rotating in nature. That means early systems are used as a combination of magnetic and rotating amplifiers, which will be treated as one of the regulators. So most of that new systems uses electronic amplifier regulators, which will change over according to the input requirement. So this diagram will better shows about field controlled alternator rectifier excitation system. So this is our main field. This should be controlled by one of the controlled rectifier and exciting to the armature case. So here stationary diode is connected. This should follows the slip ring arrangement, and DC regulator, AC regulators are coupled to the controlled rectifier case. That means slip rings are connected at main field winding, and this is supported by one of the generator armature case. So the supporting part of the armature is connected with CTs and PTs, and DC regulator is connected to the DC reference point. Here it is connected with AC reference point. All are connecting together with the auxiliary inputs case. That means the entire system is now considering with field controlled alternator rectifier excitation systems. So here DC output to the main generator field is supplied through the slip rings when non-controlled rectifiers are used. That means the regulator controls the field of the AC exciter. So here the alternator is supplied with controlled rectifier excitation system. This is about AC exciter, which is connected by field winding, and this is superimposed on the armature case, and the system is now stationary controlled rectifier. This is shown here. This will be backendly supported with excited, and this is connecting to the slip ring arrangement. This is called main field setup, and this is one of the DC regulator. They are both coupled each other with AC regulator and connecting to the blocks of stationary controlled rectifier. So this system is called generator armature, and this is supported by CTs and PTs, and DC regulator is maintained by DC reference circuit, and this AC regulator is maintained by AC reference circuit. All are connecting to the auxiliary inputs case to the AC regulator case. This will better control over the system voltage through the slip ring arrangement, maintaining the field winding, and this will maintain the constant case. When controlled rectifiers are going to be used, the regulators are directly controls the DC output voltage of the exciter system. That means we are going to consider brushless excitation system. So what are these brushless excitation system means? This is connected by one of the armature or a pilot exciter system, and here field is going to be excited with north and south poles with armature. This setup is called AC exciter, and it is connecting to the one of the controller set with the field case. The entire block is to be known with rotating structure, and here we are connecting main generator to the field and armature. These are connecting with CTs and PTs respectively. So the feedback path is given to manual control or auxiliary inputs to the regulator system. Finally, the regulator is fed back to the controller through the three-phase AC supply, and it is maintaining the field as constant. Likewise, the initial and final ends of the blocks of the brushless excitation systems are they made one of the either sides of the feedback path to the three-phase AC system to the armature case. So here the need for slip rings and brushes are eliminated. That means such systems are called brushless excitation systems. They were developed to avoid the problems with the use of brushes. So sometimes we may expect with the sparks, and the brushes may be burnt out. There may be blown at the brushes case. That's why we have to make the lack of this brush concepts, and which will be perceived to exit when supplying the high field currents of the large generator cases. So they do not allow direct measurement of the generator field current or voltage case. What are static excitation system? So usually All components are static or stationary supply DC directly to the field of the main generator, through which slip rings of the power supply to the rectifiers is given from the main generator or the stationary auxiliary bus, where it may be with the substation, and this may be alternatively existing from the auxiliary bus, which is connected with the three-phase AC, and it is connecting to the exciter transformer connected by controlled rectifier. So this block is connecting to the one of the slip ring arrangement, followed by DC and AC regulators on either sides. This block will containing to the connecting path to the controlled rectifier. So the ends of these paths are making DC reference as well as AC reference. So one of the CT and PTs are following to the armature set, and they are supposed to be excited by one of the auxiliary input sets for the AC regulator case. So this totals or some combination is dealt with the potential source controlled rectifier excitation systems. So coming to this, excitation power is supplied through a transformer from the main generator terminals. They are supposed to be regulated by a controlled rectifier. Commonly it is to be known as bus fed, transformer fed, static excitation systems. So these are very small inherent time constant. So maximum exciter output voltage is dependent on input AC voltage. This may be happens during the system faults, availability of the ceiling voltage that should be required to reduce. Likewise, it should be follows. So here in the excitation system, the power to the exciter is formed by utilizing the current as well as voltage of the main generator. That means this will be suitably achieved through a power potential transformer, that is called PPT. And also it is done with saturable current transformer, SCT. So the regulator controls the exciter output through which controlled saturation of the excitation transformer during a system fault is taken place. So with the depressed the generator voltage, the current input which will enables the exciter to provide high field forcing capability, which makes the system to be smoothened under power potential transformers and saturable current transformers. That is PTs and CTs will come into the contact to operate the main generator under normal power potential cases. So this is the diagram which will determines compound source rectifier excitation system. Here the path is connected with the saturable current transformer. The another end is connected to the neutral grounding, and the forward path is connecting to the main generator space. So here it is excited with the armature winding, and one of the block is fed back to the regulator case, and it should be connecting to the current source through the power rectifier circuit, and this path is connecting to the slip rings via field winding case, and the blocks are connecting through the voltage source by line reactor means, which should be nullifying the whatever the distortions existing in the line. So which is excited by power potential transformer, and CTs, PTs, they will share the difference in the circuit component cases. Coming to compound controlled rectifier system. What is compound controlled rectifier system means? It utilizes the controlled rectifiers in the exciter output circuits and the compounding of voltage and current within the generator stator that may result in a high initial response. Static systems with full fault on forcing capability. That means Generex compound controlled rectifier excitation system is shown here. That means here it is representing excitation transformer, this block, and the whole block is covered with the generator frame to protect it from external distortions. Armature is connecting to the excitation transformer path, and this path is connecting to the base P reactor's case, and field is exciting here through the slip ring arrangements. So one of the rectifiers with the shunt thyristor control arrangement is preferred for make of suitable operation to the DC regulator circuit. So they are coupling through the slip rings, and one of the AC regulator is provided by the DC reference circuit. and CTPTs are connecting or tying together to the AC regulator means auxiliary inputs are ready to make the system simple, and it can be easily applied with AC reference signal case. So all this information is provided from generics compound controlled rectifier excitation systems, which will make the use of the excitation systems to the limited extent. Control and protective functions. Usually, modern excitation control systems are more than a simple voltage regulator. That means it includes a number of control, limiting, and protective functions. So here, which will assist in fulfilling the performance requirements which are identified earlier. That means whatever the diagram that will expecting to illustrate the nature of these functions and the manner in which they may ready to interface with each other. So that will be shown here. This is called excitation system control and the protective circuits. Here we are going to consider two regulator arrangements, DC regulator and AC regulator. Here it is need to adjust the DC voltage. Here it is need to adjust the AC voltage. One of the voltage sensing device is connected to the DC voltage regulator. These both DC and AC voltage regulators combinedly connecting to the exciter circuit that will be connecting block to the field shortening path. This field shortening path is ready to connecting to the generator case, and the system is stabilized under voltage sensing arrangement. So the final path is connecting as return path to the voltage sensing and load compensation equipment. So this can make over to the sensing of the voltage or compensating the load conditions. So the beneath path of the AC voltage regulators are connected by the blocks of excitations of the system stability circuits, and also maximum exceeding limiters also considered under exciter limiter conditions. So this will finally connecting to the blocks of volts per hertz under limiter and protection condition to the AC voltage regulator case. That means your field shortening circuits are applicable to AC and static exciters only limited. That means some systems have open loop DC regulator and which may function at maximum exciter limiter may also be used with the DC regulator. Yes. So here control, limiting and protective functions are introduced. They may give the system which will include only some or all of these functions, which will depending on the specific applications and the type of excitation control that may functions in regulating the specific quantities. That may be at the desired level, limiting to the functions that will ready to prevent the certain quantities from exceeding set limits if any of the limiters are going to fall. So then protective functions will remove the appropriate components, or it may ready to run the unit from the service requirements. So here one of the two regulators, AC and DC regulators are existing means here its basic function is to maintain the generator stator voltage in addition to other auxiliaries. They will act through the AC regulator circuit. And another one is a DC regulator means which will holds the constant generated field voltage under manual control case that is ready to use for testing and startup, and when AC regulator is under faulty in condition. So these are some of the references which I have selected for making this presentation well, and this will give the more information in further lectures that will be developed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.